Welcome. Welcome to the deep dive.
Hmm.
We're about to unpack something that might seem, well, utterly absurd in the 21st century. But it has a surprisingly long and truly fascinating history.
Uh-huh.
I'm talking about the very shape of our world. Just a few years ago, we saw something truly wild. Mad. Mike Hughes, an amateur rocket enthusiast, tragically died trying to launch himself 2,000 feet into the air.
Right, I remember that.
His mission? To prove the Earth is flat. I mean, how can a belief like that persist today when we have such overwhelming information at our fingertips?
It's a compelling question, isn't it? Our deep dive today is all about understanding that paradox. We'll explore the incredibly long history of how humanity came to understand Earth's true shape,
Okay.
examining both the undeniable empirical evidence and, just as crucially, the surprising psychological reasons why some individuals still hold on to the idea of a flat Earth.
Right.
This isn't just about what we know, but how we know it and, why some choose to believe otherwise despite everything.
And before we go any further, let's tackle a persistent misconception, one that's surprisingly common.
Yeah.
The idea that people in the Middle Ages or during the Renaissance, or even Christopher Columbus himself, believed the Earth was flat. You know, the brave explorer sailing off the edge of the world.
Ah, that old myth. Yeah, that narrative, which gained traction in the 19th century, often attributed to writers like Washington Irving. He framed it as a triumph of modern exploration over religious dogma.
Right.
It's simply not true. Ancient scholars, figures like Aristotle, and thinkers throughout the Roman Empire had already concluded the Earth was spherical.
Really? So they knew back then?
Oh, absolutely. They were making observations like ships disappearing hull first over the horizon that clearly demonstrated a curved surface. So, yeah, the idea of a flat Earth was just as fringe in the year 1417 as it is today, basically.
Okay, wow. So let's unpack this then. How did these brilliant ancient minds, without satellites or fancy telescopes, manage to figure out our planet wasn't flat?
It's truly ingenious, really. It relied purely on observation and deduction. Early civilizations, particularly the Greeks and Egyptians, were incredibly observant. Think of Eratosthenes, around 240 BC. He calculated Earth's circumference with remarkable accuracy.
How did he do that?
Well, his insight came from observing that on the summer solstice, the sun was directly overhead in Syene, no shadows in a deep well.
Okay.
But 800 kilometers north in Alexandria, at the exact same time, the sun cast a shadow at a 7-degree angle.
Ah, okay. And if the Earth were flat, the sun's angle and therefore the shadows would have been identical in both places, right?
Exactly. The difference in angles could only be explained by a curved surface.
Right.
His calculation, based on that 7-degree difference representing about 1/50th of a circle, gave him a figure remarkably close to Earth's actual circumference.
Wow.
Yeah. And later, around 150 AD, Ptolemy's treatise Geographia introduced a system of global mapping coordinates, latitude and longitude in degrees, which, we still use today.
That whole system.
That entire system is fundamentally based on a spherical Earth.
What an incredible feat of ancient science.
Mm-hmm.
And these were just abstract ideas. There were, everyday observations that anyone could make. What's a classic example that reveals Earth's curvature, even without special equipment?
The disappearing ship is a perfect one, a real classic.
Okay.
Imagine you're standing on the shore watching a ship sail away. You'll notice the top of its mast remains visible long after its hull vanishes over the horizon.
Ah, yeah.
Or if you're a sailor climbing a mast, you can suddenly see farther. This isn't just about distance, it's about the curve of the Earth progressively hiding the lower parts of the ship as it dips below the horizon.
So it's not simply shrinking due to distance, it's actually moving out of view. That
Yeah,
makes so much sense.
precisely. Another powerful piece of evidence is lunar eclipses.
Right, the moon.
When Earth's shadow is cast upon the moon during an eclipse, it is always a dark circle. Always.
Okay.
The only shape that consistently casts a perfectly round shadow, regardless of its orientation, is a sphere.
Right, unlike a disk, which would be an oval sometimes.
Exactly. A flat disk, if angled, would cast an oval shadow. Plus, a flat Earth would imply that lunar eclipses are visible from the entire Earth at once, which they are not.
That consistent circular shadow is a powerful visual.
Now, what about the stars? Do they offer any clues?
Absolutely. The visibility of different stars from different latitudes is a strong indicator. Aristotle himself noted that certain stars were visible from Egypt, but not from Europe. If Earth were flat, you'd theoretically see the same stars from everywhere, just perhaps appearing smaller or dimmer.
Right.
A more personal anecdote comes from Ibn Rushd, who traveled from Cordoba to Marrakesh in 1153 just to see the star Canopus, which was invisible from his home. This clearly demonstrates the Earth's curvature.
That's a dedicated stargazer. You also mentioned there's some surprising ways to witness the Earth's curve for yourself. What's an example?
Yeah, there's a fun one you can try at a beach.
Oh.
Watching the sunset twice.
How does that work?
Well, if you lie down as the sun is setting and watch it disappear below the horizon.
Okay. Then immediately stand up. You can often see the top edge of the sun appear again for a moment and watch it set a second time.
No way.
Yeah. It's entirely due to the Earth's curvature, allowing you to see slightly further when your eyes are higher. It's impossible on a truly flat surface where the sun's shadow would move uniformly.
That's a fantastic trick.
Yeah.
Okay, so we've covered ancient insights and simple everyday observations. But what about proofs that require global scale, navigation, and modern technology?
Right. Here's where the evidence becomes absolutely overwhelming. The ultimate proof is circumnavigation.
Sailing around the world.
Exactly. The Magellan expedition in the early 1500s was the first to sail completely around the Earth. They even famously lost a day in the process.
Oh, yeah?
Which later led to the concept of the International Dateline.
Wow.
Since then, countless circumnavigations by sea and air have repeatedly confirmed that our planet has no edges. You can just keep going in one direction and end up where you started.
And I know flat Earth theories often involve Antarctica as some sort of ice wall around the disk. How does that idea hold up?
It doesn't, really, not at all. In some flat Earth models, Antarctica is posited as this impenetrable ice wall encircling a disc-shaped Earth.
Right.
But Antarctica is a well-mapped, traversable continent. It's smaller than South America, but larger than Australia. Its observed size and the fact that people have crossed it.
Like completely crossed it.
Yeah, a full land crossing in the 1950s. It completely contradicts the ice wall idea. On a flat disk model, Antarctica would have to be massive, like over 6 times larger than the Arctic Circle to encircle the whole thing. That's just not what we observe or experience.
It's amazing how fundamental things like day and night or time zones also logically point to a spherical Earth.
They're direct consequences. On a spherical Earth, roughly half the planet is always in daylight and the other half in darkness.
Makes sense.
This naturally creates time zones, with sunrise and sunset occurring at different times across longitudes, about 4 minutes per degree. This is why, if you call a friend in San Francisco from Richmond, Virginia at sunset, they'll still have 3 hours of daylight left. That 3-hour time difference reflects a 45-degree longitude separation.
Right.
A spotlight sun model proposed by some flat earthers simply can't explain the observed angles and consistent behavior of the sun across the globe. It just doesn't work.
And what about the changing lengths of day and night throughout the year? That's not always the same everywhere.
That's elegantly explained by Earth's axial tilt of 23 degrees.
The tilt, right.
As our spherical Earth orbits the sun, this tilt causes varying lengths of day and night, especially near the poles where you can get 24-hour lighter darkness for months. Also, twilights are longer at higher latitudes because the sun's angle relative to the curved horizon is shallower, meaning the atmosphere stays lit for longer even after the sun dips out of sight.
So physics itself prevents a flat Earth from existing as a stable body. What about gravity, for instance?
Absolutely. The laws of gravity are incredibly well-tested and fundamental. They dictate that any non-spherical planet the size of Earth couldn't support its own mass.
What would happen?
Well, a disk the size of Earth would actually crack, liquefy, and then reform into a roughly spherical shape due to its own gravity pulling everything towards its center. It's a fundamental principle of planetary formation.
But I've heard some flat earthers argue that objects fall due to density, not gravity, or that the Earth is constantly accelerating upwards.
Yeah, those counter-arguments fall apart under scrutiny. Experiments like David Scott dropping a hammer and a feather on the moon.
Oh yeah, Apollo 15.
Or Brian Cox demonstrating the same in a vacuum chamber on Earth, unequivocally show that all objects fall at the same 9.8 meters per second squared acceleration, regardless of their density. Density matters for buoyancy, not free fall in a vacuum.
Okay.
And the idea of upward acceleration is also inconsistent with observed phenomena like tides. And I mean, if it were true, Earth would quickly approach light speed, which is clearly not happening.
And even weather patterns, like hurricanes, also have something to say about Earth's shape, don't they?
They absolutely do. Weather systems like hurricanes, which are low-pressure systems with inward winds,
Right.
they spin counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. This is a direct result of the Coriolis force,
The Coriolis effect.
which only exists on a rotating sphere. It's a powerful, observable phenomenon proving Earth's rotation and spherical nature. You just can't explain it on a flat, stationary model.
This brings us to modern technology, which provides, well, undeniable proof. The Foucault pendulum comes to mind.
Ah, the Foucault pendulum. First demonstrated by Léon Foucault in 1851, it's a simple yet profound experiment.
How does it work again?
Well, a long, heavy pendulum's plane of oscillation appears to rotate over time, but it's actually the Earth rotating beneath it.
Gotcha.
The rate of this precession varies with latitude. For example, it takes about 31.7 hours for a full rotation in Paris and 36.7 hours in New York City. At the poles, it's 24 hours. At the equator, it doesn't rotate at all.
Interesting. And what's truly fascinating, maybe a bit ironic, is that in the documentary Behind the Curve, a group of flat earthers, attempting to disprove Earth's rotation using a ring laser gyroscope, accidentally proved it. They observed the expected 15-degree-per-hour drift.
Talk about an ironic aha moment. And what about the tech we rely on every day, like GPS?
Yeah, I mean, every global navigation system, including GPS, GLONASS, Galileo, they all operate on the fundamental assumption of an approximately spherical Earth.
They have to, right?
They absolutely have to. Their incredible accuracy in pinpointing your location directly confirms this model. Furthermore, countless satellite images from orbit unequivocally show a spherical Earth.
Yeah, the pictures.
Astronauts in low Earth orbit can personally see the curvature of the planet, and those who traveled to the moon have seen the entire Earth, watching our sphere rotate once a day. You can't really argue with that view.
It sounds like large-scale engineering also has to factor in Earth's curvature. Oh, definitely. Engineers build huge structures with Earth's curve in mind. From the precise calculations required for colossal structures like the Humber Bridge in the UK.
How does that work?
Well, its towers are deliberately built slightly farther apart at the top than at the bottom, about 36 millimeters, to account for the Earth's curvature over that distance.
Wow.
To the simple fact that high-altitude aircraft pilots and even skydivers clearly see our planet's curve, engineering itself confirms a sphere.
Right.
Even the supersonic Concorde could literally outrun the sunset, allowing passengers to see the sunrise in the west and then set a second time in New York. These are all things impossible on a flat plane.
So with all this undeniable evidence, from ancient observations to cutting-edge technology, why then do some people still genuinely believe the Earth is flat? It seems counterintuitive.
This is where we step into the fascinating and complex realm of human psychology. The modern flat Earth resurgence is real. YouGov polls have shown a significant percentage of young Americans aged 18 to 24 express doubt about Earth's roundness.
That's surprising.
It is, and celebrities and social media have certainly amplified this movement.
So what are the primary societal and psychological factors driving this modern flat Earth resurgence beyond just, a lack of scientific understanding?
Well, a core factor seems to be a broader societal shift towards populism and a profound distrust in traditional gatekeepers of knowledge, academics, established scientific agencies, government.
Right, the experts.
Exactly. This creates an environment where once fringe views can easily gain traction, especially when influencers, even without traditional expertise, are often seen as more authentic or relatable. They can be better storytellers, which can hold more sway than dry facts sometimes.
And social media clearly plays a huge role in fostering this flat Earth ecosystem.
Oh, absolutely. Platforms like YouTube become a central content hub, essentially an alternative documentary channel for flat earthers, often with daily or weekly shows.
Like their own news channel.
Kind of, yeah. And Facebook and Twitter are used for administrative functions and messaging. This creates what some researchers call an effect addict environment that thrives on intense emotions and, frankly, misinformation.
How so?
A common example is the misinterpretation of the UN logo, which is a specific type of map projection called an azimuthal equidistant projection, centered on the North Pole.
Okay.
It shows the continents accurately relative to the center point, but distorts shapes and sizes further out. Flat earthers often point to it as proof the Earth is flat as depicted on the flag, but it's just one way of mapping a sphere onto a flat surface. People often see what they want to see or what confirms their existing suspicions.
So it's not just a lack of information, but perhaps a different way of processing information.
Precisely. Research identifies conspiracy mentality as a distinct cognitive style. It's not just about what you believe, but how you think.
How does that work?
Well, conspiracy beliefs correlate with intuitive, heuristic-driven System 1 thinking, quick, emotional judgments, gut feelings. And they negatively correlate with slower analytical system 2 thinking, which involves more critical evaluation and effortful reasoning.
Can you break down some of the specific cognitive biases at play here, the sort of mental shortcuts?
Of course. So first, we have formation biases, which help explain why these beliefs might start in the first place.
Okay.
There's the conjunction fallacy, where people overestimate the likelihood of two unrelated events co-occurring and being causally linked. A classic example often cited is the umbrella man at JFK's assassination. Just a guy with an umbrella, but some saw it as a signal in a conspiracy.
Right, seeing connections that aren't there.
Exactly. Then there's proportionality bias, the tendency to believe that big events must have big causes. So a global pandemic, for example, is easier for some to attribute to a vast secret conspiracy rather than, say, a natural virus spillover from an animal. The cause feels more proportional to the effect. And agency detection bias is when people over-attribute intention or purpose to random events, seeing a plot where none exists. This can often lead to anthropomorphism, too, attributing human traits or motives to non-human things or complex systems.
And once these beliefs are formed, why are they so incredibly difficult to change, even with all the evidence we've discussed? It seems like showing someone a picture from space should do it.
That's where updating biases come in, making these beliefs incredibly resilient. Confirmation bias is a huge one.
We hear about that a lot.
Yeah, it's the strong tendency to seek out, interpret, and recall information that confirms your existing beliefs while ignoring, discrediting, or explaining away contradictory evidence.
So any evidence against the belief is just part of the cover-up.
Essentially, yes. This makes conspiracy theories inherently unfalsifiable. Any attempt to disprove them is just seen as further evidence of the conspiracy. It's like a built-in defense mechanism for the belief system itself.
It sounds like a closed loop, very hard to break out of.
Exactly. Then there's availability bias, where something is believed more readily if it's frequently repeated or emotionally vivid.
Like seeing lots of YouTube videos about it?
Precisely, which is constantly fueled by media exposure, especially on platforms like YouTube. And finally, overconfidence, sometimes called explanation hubris, is when people overestimate their own understanding or the explanatory power of their beliefs.
The I did my own research effect.
That's often how it manifests, yes. It leads to a resistance to new information, even from genuine experts, because they feel they already understand it better.
And there's a significant social cost to holding these beliefs, which must make it even harder to let go.
Unfortunately, yes. The documentary Behind the Curve really highlighted this. Flat Earth beliefs can lead to people losing friends, family, romantic partners.
Wow.
If your entire social community becomes centered around this belief, abandoning it means losing potentially all your remaining relationships. That social pressure makes it incredibly difficult to change one's mind, even if doubts start to creep in, purely separate from the cognitive biases.
So simply debunking these beliefs often doesn't work, and can even backfire. Just throwing facts at people isn't the answer.
That's correct. Research shows that directly refuting a deeply held conspiracy belief can sometimes strengthen it, the backfire effect. Instead, the focus should ideally be on debiasing, making people aware of their own reasoning processes and cognitive biases.
It's like metacognition, thinking about thinking.
Exactly. Helping people recognize these biases in themselves might help them critically evaluate information more effectively in the future. It's about building a better mental toolkit rather than just attacking a specific belief.
That's a fascinating journey, really, from ancient observations using shadows and sticks to the complex psychology of belief in the internet age.
It really is.
We've seen the breadth of evidence, from Eratosthenes' clever shadows to the precise calculations of GPS satellites, all unequivocally proving Earth's spherical shape. But just as compelling, we've explored the intricate human reasons why some still hold on to a different view.
It truly highlights that knowledge isn't just about accumulating facts, is it? It's also about how our minds process information, how we interact with sources, our trust in institutions, and our fundamental social needs.
Indeed. So maybe the final thought for you, our listener, is this. In a world where we can map a sphere with incredible precision and even fly around it, what does it truly mean to seek knowledge and distinguish fact from elaborate fiction, both in the cosmos and, perhaps more importantly, within ourselves?
Yeah.
We encourage you to embrace critical thinking, not just for the shape of the Earth, but for all information you encounter, especially online.
It's about valuing rigorous thought, remaining open-minded to genuine evidence, and understanding the complex interplay between facts, perception, and belief in every aspect of your life. It's a continuous process.
That's a deep dive for the ages. Thank you for joining us on the deep dive. We hope this exploration helps you navigate the complex terrain of information and belief with a renewed sense of curiosity and critical thinking.